Hello, my name is Utkarsh, and today I'll be talking about multi-threading and multiprocessing. I'll be talking about them individually, and I'll be also explaining what's the difference between them. So let's start with multi-threading. But before we start with multi-threading, let us understand what thread is. Thread is called a lightweight process. Threads provide a way to improve application performance through parallelism. That is, you can say that thread is sort of a task that is inside a process. Now let's come to multithreading. Multithreading is the ability of a CPU to execute multiple threads at once. Multithreading allows the execution of multiple parts of a program at the same time, hence maximum utilization of CPU. This means that a process can be divided into multiple threads or multiple tasks, and these tasks can be run in parallel, and hence the process can be done more efficiently and in a smaller span of time. Now, I'll be explaining about what is threading and what is multi-threading and their difference. So a single thread has a register, a stack, its code, data, and files that it shares from the main process. But what about multiple threads? Now, multiple threads do not get their individual code, data, and files. Multiple threads have their own registers and stacks, but they too share their code, data, and files from the main process. Now, let me tell you about multi-threading through an example. Here, I have performed multi-threading through C programming. Here, I have created a function by the name hello that takes a character input and prints it. In the main, I have created three threads, namely TID, TID1, and TID2. All of these three threads give different character inputs to this function hello. Now, if I pass this hello world in the TID thread to this hello function, this prints it and then exits. Same happens with the TID1 thread and TID2 thread. Now, you will be asking, what is the difference if I just write printf in parallel? Well, there's a huge difference. Now, if I write printf line by line, then all of these three printf statements will be executed sequentially. But what happens in pthread is that all of these three are created all at once, and they call the function at the same time, and hence all of them get printed at the same time. So if a single printf statement, let's say, takes 1 clock cycle, then 3 printf statement might be taking up to 3 clock cycles. And this pthread create might do that whole job in just 1 clock cycle. So see how efficiently we have done all of this. Now, you might be asking that this is such a simple task. Well, pthreads can also be used to do something much more complex, such as the calculation of a million numbers or the sum of a million numbers. So let's say that I want to get a sum of the first 1 million numbers. What do? Calculate them individually? Of course not. I can do this by multi-threading. Through multi-threading, I can divide those 1 million numbers into 4 parts and then assign each one of the part to a particular thread. This thread will calculate it and then give the output. And then using this pthread join, I can combine all of those outputs and then hence get a particular output that I was looking for. So see how a complex task can be divided and done parallelly through multithreading. Now, let's move on to multiprocessing. Now, multiprocessing is basically just doing multiple processes parallelly. So let us understand first what is a process. A process is basically a programming execution. That is, if we write a program in a programming language and put it in execution, it becomes a process. So there is one main thing with process is that all of those processes must progress in a sequential fashion. But what is multiprocessing? Well, multiprocessing is in which 2 or more processing units control the function of the computer, and they individually handle all of these processes. So rather than coming in sequentially, these processes get passed on to multiple processes which execute them parallelly. Hence, similar to multi-threading, they also do a bigger job in a smaller amount of time. So we can either perform this multiprocessing by using multiple processes, or we can use system calls to create multiple processes inside a single CPU. Now, let us see what this is. So first, let us see what is uniprocessing and what is multiprocessing. Now, first, I have taken an input here. So when I take an input inside a uniprocessing environment, then this input gets passed on to the CPU. The CPU calculates all of this and does the computation, and the output unit displays the output. But what if multiple processes arrive? Well, they are queued and have to wait until this process gets completed, and then their chance comes. But what if I want to execute them all at once? Well, not all at once, but I can execute few at once by using multiple processors, like in this block diagram. So let's say if two processes arrive, then one does not have to wait. So this process gets passed on to this CPU, and the other process gets passed on to this CPU. They both execute parallelly and hence give outputs independently. So here we have taken just half the time that might be able to do two processes. Now, let us understand how this multiprocessor works. So, this method is known as a master-slave system. So, in a master-slave multiprocessor system, the master CPU is in control of the computer and the slave CPUs perform the assigned tasks. Now, these CPUs might share common resources or might have separate resources assigned to them specifically. This means that if it's such a trivial task, such as calculation of a roots of equation, then it might be done by any CPU. But if like we have to calculate the graph of a particular equation, then it might be just possible using a specially customized CPU, then it has to be allotted with particular and specific resources. Now, it is not necessary that the master has always to order the slave. So the roles of master and slave can change from one CPU to another. Now, to explain this multiple processor concept, let us take an example. So here I have taken an example of 8255 microprocessing unit that is interfaced with 8086 Intel microprocessor. Now, this 8255 is generally known as an interrupt handler, and it can handle up to 8 interrupts. But not just that, 8255s can be interfaced among one another also. How? Let us see. So let us say this is a master processor of 8255. This is an 8086, and this is an IO device. So one 8255 can be interfaced with 8 other 8255s, which in total can handle up to 64 interrupt requests. Yes, that's a huge amount for a uniprocessor system. Now, if an interrupt comes, then this master 8255 will pull all of those slave 8255s, and then whichever is free will accept the process and will perform and give the output back to the master processor, which in turn will give it to 8086, which in turn will give back it to the IO device. Now, let's see how multiprocessing is done using system call. Now, if we only have one CPU available and we want to perform multiprocessing, then we can use a system call known as fork. When we get the same type of code repeatedly, then we use the fork process call. Here, the process is cloned and a child process starts running parallel to the parent process. This means that if a fork system call is called, then a new process gets created and it starts running parallelly to the main process. Let me explain this using a block diagram. Let us say that we have one parent process and we call fork one time. A child process is created and the child process gets its own ID and the parent process has its own ID. Now, what if I call fork a second time? Well, another child process gets created and it has this child process as a parent process. But not just that. Another child process gets created from the main parent process and it has its own separate ID and its parent is the main parent process. So yes, each time I call fork, all of the processes gets their own child processes. So if I call fork another time, then all of these 4 processes will have their individual children. So you can see that fork expands in an exponential manner and hence can reduce the time exponentially. But it just has one slight disadvantage. That is, fork clones a process. That is, if I want to perform a different process than the usual process, then I cannot do it with fork. Now, let me explain how you can limit the number of processes inside a fork. So let us say that I just want to create 3 processes. Well, let us start with forking once. So when I fork once, this parent process is created. Then its child processes gets created like this. But if I call fork the second time, then this child process gets created with the parent ID of this child process. But where is the child process from this main parent? Well, it does not get created because if is inside a conditional statement known as if else. So if we want to limit the number of processes made inside fork, we just have to do it inside the conditional statements. Now, you might be familiar with multiprocessing and multithreading, but most people use these terms interchangeably. And let me just one more time explain you what is the main difference between them. So in multiprocessing, multiple processes execute at a single time, while in multithreading, multiple threads of a single process execute at a time. This means that in multiprocessing, there are multiple processes, while in multithreading, there is a single process which is divided into multiple tasks or multiple threads that execute parallelly. So multithreading can be seen as an extension of multitasking. Now, the time taken to create a separate process is much more than creating a new thread. This is because whenever we create a new process, it has to be allocated with memory space and its own resources, which takes a lot of time. Now, each time a new process is created, an address space has to be allocated to it, but this is not the case with a new thread since it shares the same address space of the main process. Now, multi-threading is a user level process. That is, if I want to create a thread, I can create it by myself and I can manipulate it upon my needs. But that's not the case with multiprocessing. If I want to do multiprocessing in a single CPU environment, I have to use system call, which is a kernel level process. And hence, I myself as a user cannot customize it or cannot use it according to my needs. So multiprocessing is sort of a kernel level thing and multi-threading is a user level thing. Now, let us talk about context switching in multi-threading and multiprocessing. Now, since multiprocessing has to go through multiple uh, resource allocations and allocation of an address space, it is much more difficult to do context switching, or let's say it is much more tedious to do context switching in multiprocessing. Since the current process has to be saved, then it has to switch from the current process to the next process, and the next process has to be started. This takes a lot of time as compared to multi-threading, where in which only we have to switch between registers and stacks since all other resources are shared. Up till now, you might be wondering what is the use of multiprocessing if multithreading is much more faster and has much more benefits. Well, let's just say that multithreading has also its fair share of disadvantages too. Let me explain this with an example. Now, let us say that there are multiple threads created in a single process, and one of those threads needs to be halted because it wants an IO interrupt or it wants to access a memory location. So it asks the kernel that it has to be halted. But since all of those threads are made by the user, kernel does not recognize them. Yes, so it recognizes the whole process as a complete process and not those threads. So it will halt the process as whole. Due to this, all of those other threads that had been formed also have to be halted. So the whole process has to be halted just because one thread asks for an IO interrupt or a memory access. But that is not the case in multiprocessing. In multiprocessing, if a child process gets halted, it does not mean that the parent process also gets halted. The parent process might be running and the child process can ask for an IO interrupt or a memory access without disturbing the parent process. So we can conclude by saying that the multiprocessing is an independent process while multithreading is an interdependent process. Here in this block diagram, you can see that the main process is divided into multiple processes which have their own CPU and memory, while in multi-threading, the main process has one CPU and one memory and is divided into multiple threads or multiple tasks. So I hope that you have understood about what is multiprocessing and what is multi-threading, and you have also understood what is the difference between them. Thank you.